All right, ladies and gentlemen, welcome back. Today, I'm going to go over a phase change diagram. So I actually kind of like to equate this to something else a little bit, just to kind of get you to understand the concept, and then I'll relate the concept back to a phase change. So let's say you decide to go on a road trip, okay? So you're going to be traveling, so the distance you'll be traveling, okay, as time passes, is going to increase, okay? So as you're traveling on this road trip, you find yourself stuck in the middle of the highway as you wind up blowing a tire. So now you have to pull over and you have to change your tire. Even though time continues to pass, you don't change your distance because you wind up blowing a tire. So now you can't drive anymore. You have to focus on making sure your tire is changed. So once you finish changing your tire, now you get back on the road and you can focus on driving back to your destination. Pretty simple concept, right? Okay, so as you can see, time continued to flow. You went on your trip, you stopped to change your tire, and then got back on the road and continued on to your destination. Well, we're going to change the parameters a little bit, and this is not going to be distance. This is actually going to be a change in temperature. Okay? So let's say we have a container of water that's been sitting in a freezer for about a week that is set at negative 10 degrees. So the container has a block of ice at negative 10 degrees Celsius. Okay? We take that container out, and let's say we put it outside during a hot summer day, more than 100 degrees, so a really, really hot summer August day. Okay? So this container will immediately start taking in thermal energy from the environment. The thermal energy will flow into the container, and it will start to increase the temperature of the ice. And as the ice is increasing in temperature, it is going to continue to increase in temperature until you get to 0 degrees. So the energy has gone to changing the whole temperature of the system. But once you reach 0 degrees, now it shifts from changing the temperature of the system to changing the state of the system. So here we have a solid, and here we are changing from a solid to a liquid. Much like you could not focus on changing both the tire and driving, you either had to be changing the tire or driving, you cannot change both the temperature and the state of the system at the same time. You are either changing the temperature or you are changing state. It's only one or the other. So once it continues to change the state, it finishes changing state, and now we have a complete liquid in the container. The container will continue to change temperature until one of two things happens. Either it reaches equilibrium with outside, or in the case, because it is over 100 degrees outside, it reaches the next change of state, which at 100 degrees is the boiling point. So it is a liquid here, and here it will change from a liquid to a gas. And at this point, once again, the temperature stays consistent as energy continues to enter the system, and it changes from a liquid to a gas until ultimately the entire system has changed into a gas, and then the gas will continue to increase in temperature until it reaches equilibrium with the environment. Okay, so once it reaches the same temperature as the environment, there will not be an energy flow in either direction, and you've completed your phase changes. Now, one thing I do want to point out, we've talked about energy moving in and out of the system. The change in temperature from a solid to a liquid, and the change in temperature, or I'm sorry, the change in state, excuse me, from a solid to a liquid, and the change in state from a liquid to a gas can happen in either direction, and they happen at the exact same temperature. What is important is the direction of energy flow. So here, if a solid is changing to a liquid, that means energy is entering the system. It is your freezing point. Here, if it is turning from a liquid to a solid, oh, I apologize. That was wrong. I got ahead of myself. This is the melting point. My bad. Here, if energy is leaving the system, molecules are slowing down, the system begins to solidify. This is the freezing point. Okay? Freezing and melting happen at the exact same temperature. The direction of energy flow dictates what's going to happen. Here, again, if energy is entering the system, you are boiling. And if energy is leaving the system, you are condensing. So I hope that's been helpful in terms of understanding phase changes and the phase change diagram and understanding the direction of energy flow. If you have any questions or there's something you need me to clarify, please feel free to send me a message and I'll be happy to answer you. Take care and have a wonderful weekend.